All right, this is a quick video on axis deviation, and I really want to try to keep this short because I know your time is precious in medical school, and I hate long videos. So we're going to jump right into it. So why do we use axis deviation in the first place? Well, let's imagine that we have some ischemia right here, and I picked blue for cyanosis, obviously, right? So if we have current coming in, it is going to go away from that, pretty much around it, but away from it. So we can always think about our axis deviation is going towards hypertrophy because as it comes to this, it's creating bigger muscle and it's going away from damage or away from ischemia. That is like one of the main fundamental reasons for using axis deviation, why it's important. So if we go over here, I know everybody's familiar with this. This is our circle of axis. I put cameras, I guess, from the 1950s all the way around this whole circle here, and it shows which way they're facing. So our cameras pretty much are always facing towards the center. And it's very important to remember where where each lead is looking. So AVL, I like to think this is your left shoulder. AVR is your right shoulder. One is from your side looking directly in. Two is going to be your left leg. Three is going to be your right leg. And AVF is right at the front. But why is the cameras important in the first place? And why did I make them look like they're from the 1950s? Well, I can only answer one of those questions. I don't know why they're from the 1950s, but let's imagine that you are a film director on a set. This is your camera that you're looking into, or your screen that you're watching your cameraman operate. And here he is rolling his camera. And he is filming a ball out in the distance. We'll draw a ball here because this is what you're seeing on screen. As this ball starts to get closer to the camera, the ball that you see on screen is going to slowly get bigger. Another way to conceptualize this is to put your hand out in front of your face, and as your hand gets closer to your face, it starts to look bigger and bigger and bigger. So, to bring that back into EKGs, if we have a positive deflection in any lead, that means our current is getting bigger. It is coming towards our camera. Current, well, imagine this is current here, right? Current's traveling towards our camera and it's getting bigger. And just the opposite. If we have a negative deflection, it is moving away from the camera. So for instance, let's say in lead 2, it looks like this. You put this over here. In lead 2, we have a positive deflection. That means our current is moving towards our camera. Let's say in AVR, we have a negative deflection. This means that our current is moving away from the camera. In A or V3, not V3, lead 3 will have a positive deflection. We're going towards the camera. And in AVO will have a negative deflection. It is going also, well, it is going away from the camera here. I don't know if I said towards or away, but positive deflection, lead 3 is going towards it. Negative is going away from our camera, which is here. So it's important to remember where each one of these sit. And if it helps, you can also draw it out as a stick person, which is the way I like to do it because the circle just doesn't resonate well with me. Where this is AVL, AVR, this leg is 3, this leg is 2. Oops, that is a 3. Then you have one that looks this way, and you have AVF that looks right up the front, left, right, front. So let's try to conceptualize this and put it into a little bit of practice here. So this is going to be our EKG, and hopefully you can see it on the screen recording. But we're going to look at 1 and AVF. And the reason why we look at 1 and AVF is because AVF is looking up front, and 1 is looking from the side. And this makes a perfect 90-degree angle, which makes it pretty easy to know which way our axis actually lies. So if 1 is primarily going up, we know that it is going towards our camera. Since 1 is looking this way, and we have a positive deflection in 1, we're going towards the camera. Now AVF is also going up. AVF sits down at the bottom and looks straight up at the body. So If ABF is going up, that's a positive deflection. We know it's going towards the camera. So if you look at where both of these arrows are pointing, this is pretty much a normal axis deviation. And to confirm this without even looking and know that this is probably normal, if we look at lead 2 here, lead 2 is kind of pointing right in the middle of our normal. Lead 2 should probably have a positive deflection here. And of course, boom, it does because it's going towards the camera. So this is a normal axis deviation. Now, pretty easy. I get it. We don't need a video for this. Let's go to something a little bit harder. And this is probably harder than what you'll see on an exam. But a lot of these are what we call isoelectric. So this is your isoelectric line here. And a lot of these guys are pretty much in the center. So it has the same negative as it does positive. So how do we address that? So here's a few different ways to do it. But looking at one, it has almost about the same amount of positive as it does negative, maybe like a millimeter or two more than positive than it is negative. But whatever, we'll start with ABF here. And that is a primarily negative deflection. So we'll draw our stick man again. And since we have a negative deflection in AVF, it is going away from our camera. So we can look at another lead here. We said that one was pretty much isoelectric. It might be going just a little bit more right than it is left. It's not enough to call, usually if it is a perfect isoelectric line. I'm trying my best to make this look as even as possible here. If it is perfectly isoelectric, and this is one, I like to draw a dot right in the center. Because I mean, it's not going right, it's not going left. It's kind of just sitting there in the center. So whatever, we'll skip to another one that is kind of moving. So let's look at 3 here for a second, and we're primarily going down. Remember, we said 3 sits from our right leg and points up if the camera is looking up towards the heart to the left shoulder. Since this is a negative deflection, it is going away from our camera. Just like that. Let's look at another one. AVL. This is going up. We said AVL is over here on this left shoulder. I know I keep putting this wrong. It should be like this, but you get it. AVL's on this left shoulder. This is going up, so we know that the current is going towards our camera. And I mean, at this point, you could probably get the picture of what is going on here. But just to show you even more here, let's go to 2. 2 is primarily going down more than it is going up. 2 sits over here on our left leg, facing towards our right shoulder. But since we are going more down than up, just by a little bit, we're primarily going away from the camera. We can make this a small arrow, kind of like that. If it was truly just going down, it would be going directly that way. But since it's kind of almost isoelectric, but a little bit more, it's kind of more going that way. So anyways, with that said, we could put all these together and look where our arrows are pointing. Here, 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 here. And with our, if we were to say this is going up, probably about 2 millimeters more, our V1 would probably be pointing here. We can easily say this is left axis using every single lead. We don't have to just worry about one in AVF or the tiebreaker. We can use any lead on the EKG to see where current is moving on that axis. Now, you cannot use, this is a thing I feel like I should note just because I've been asked about it, cannot really use these V1 through V4 because while our circle sits, ooh, that is a big circle. So while we have our circle of axis, looking at the heart from the foot and from the arm, from the bottom, V1 through VF is kind of looking like if this is the top of your head here, looking straight down, it is looking just like this all the way around your body. Now, there is an axis that you can calculate from these called the z-axis, but this is not relevant for our exam, so we will not talk about z-axis. So whenever you're looking at these for axis deviation, ignore all this. So we said this one was left axis, and we use every single lead to confirm that this was 100% left axis. One more example before I'll wrap this one up here. I try to pick out the hardest examples possible. I literally typed in axis deviation with isoelectric lines, and this is what I got. So Looking at lead one, it is going more down than it is going up. So I'll make the stick man this here this time. Now, again, all right, let me just show you again. Lead one, primarily down. If our lead one sits here and our camera faces just like that towards the body, since it is going down, it is going away from the camera, like, like that longer. All right. And to show you that axis deviation is not just an AV or lead one and AVF, we'll kind of just walk through these right in order from one, two, three, R, L, F. So let's go to lead two. We know lead two sits at this left leg down here and looks up towards the right arm. This is pretty much isoelectric. So I'm just going to draw kind of a, not going to erase it. I'm going to draw a dot kind of here in the middle for two. Let's go down to three. Three looks over here from our right leg up to our left arm, just like that. That's primarily going up. So it's coming towards our camera. It's getting bigger in our camera. So we're going that way. Let's go to AVR. AVR, I drew it right, or wrote it right that time. Looking from our right shoulder down to our left leg. Kind of more up than it is down. So we could say it's probably going towards our camera in this direction, but it's also probably turned a little bit because it's going down as well. But we'll make a small line just kind of going towards it. Not a big one, kind of a small one. AVL, sitting here. And we were going down, so we're definitely going away from the camera here for AVL. And AVF is primarily going up more than it is going down. AVF sits here. So if we're going up, we're primarily going towards our camera. And again, look at where all these arrows are pointing that we ended up with. So we could say this is going to be a right axis deviation. So hopefully that makes sense a little bit. The reason why I think it's pretty important to conceptualize where these cameras are facing and why it's going up, why it's going down is yes, axis deviation, 100%. Go get every single one of those questions right on an exam. But another thing is when we start talking about STEMIs and reciprocal changes or inferior MIs, and we have to move the camera for a right-sided 456R, or even a posterior where we do a 789, you'll see why are we going up in a lead? Why are we going down from a lead? Or that's not down, but down from a lead. And it shows which way our current is traveling, so we know we're going away from the damage and towards hypertrophy. This can also help confirm things like a STEMI because we do have those reciprocal changes. So, good way to conceptualize it. And just because these AVF and one may be isoelectric like it is kind of here, oops, here, we can use every single one of our leads to realize where it's going. So, hope that helps.